Thank you very much for the introduction. So thank you very much everybody for coming tonight. As Jaap introduced, I'm Donna Carroll and I teach physics here at the University of Maastricht. Tonight I want to talk to you, as you can tell from the title, I want to talk to you about time. And time is a huge topic, so there are so many things that one could discuss about time. It's possible to look at time from a psychological perspective. So if you're having a really boring day, time could go very slowly, and hopefully that won't happen this evening. I'm a physicist, so you might also think that I'll be talking about relativity theory and time dilation. But actually what I want to do is go back to the real basics. What is time? How do we measure time? How and who has decided how to divide time up into the divisions of time that we use on a daily basis? So those are the things that I want to discuss tonight. I'm going to start by taking you back to the time of ancient man. If we want to discuss what we mean about time, we need to think about how we perceive things changing around us. So if every day nothing changed, then time for us would perhaps feel unlimited. Some of my students there in the back there, they might think that some of my lectures feel like that. But fortunately for us, we see things changing in nature. And because we can look at the natural rhythms and repetitions around us, we can use these as a sort of benchmark for using a measurement of time. So if you're ancient man, can I just check, is the volume too loud on this? No? Okay, it sounds very loud down this end. Okay, so if you're ancient man and you're sitting in a field, then the first repetitious cycle that you notice in nature is, of course, the day and the night cycle. So it's very easy to see where our divisions of day and night, light and dark, come from. So that's a very obvious cycle to start with, so I'm not going to explain days any further than that. The next most obvious cycle that we have a perception of the passage of time is the waxing and the waning of the moon, and the word moon giving us the word month, so we can see that this cycle changes every 29 days, every 30 days. You get this waxing and waning pattern. And of course, for ancient man, if you turn off all your street lights and you didn't have the big cities around, then of course this is something that's very easy to spot, and it has a big impact on your life. So the first calendars and the first time measurements that you see appearing are lunar-based calendars. So there are many different examples of these that have been found, things like notches on narwhal bones. You also see examples of where ancient men have dug pits, so little circles in fields, and they're drawing out a sort of very basic lunar calendar. So that's one of the first calendar-based systems that you see coming into existence. Of course, we've talked about days and months. The next cycle that is obvious to see, and maybe it depends on which part of the world you're living in, but for us living in this part of the world, it's very obvious to see that you have the passage of seasons. So at the moment, it's cold weather, and it's very obvious to see that you go through the 4 seasons, and that gives you an idea that something is changing, and that gives you an idea of what's going on with what we call the tropical year. Of course, getting a measurement of the year is very difficult, right? Because I can't use temperature to give me an indication of exactly, has a year passed if it's now 8 degrees again? So this is where certain civilizations had a better idea of the length of a tropical year than other civilizations. So for example, if you look at what happens to the River Nile every summer, it floods its banks. So the Egyptians had a huge advantage over other places in the world with being able to accurately measure the length of a year, because they built these things, these structures called Nileometers, which I think is a great name. So these Nileometers are a sort of pit or a well in the ground with stairs coming up. And every year, these would flood, and they could measure the height of the flood, and that gave them a really good indication of the length of a year. The other things that you can do to measure the length of a year you can look at the position of the sun as it moves across the sky. So anyone who spends a lot of time outdoors, you will notice that the position that the sun is rising on the horizon and setting in the horizon changes as you go across your year, and the position of the noon or the midday sun is also changing across a year. So that's why you see structures like this, like in Stonehenge, which is very famous, but there are many other examples of this, which were designed to measure the length of a year, a solar year, depending on the position of the sun. So you would wait until the sun returns to that same position, and that gives you an excellent indication of your length of solar year. If you look at the position of the sun, at midday, precisely noon, every day of the year, you will also see that the sun draws out this beautiful shape across the sky, and you see photographers doing this with very fancy sun filters. And this shape is known as an analemma. And actually, if anyone's got kids at home, this is a really nice experiment that you can do. You don't have to do this with fancy cameras and fancy equipment. You can actually do this looking at shadows. So if you stand in the same position in your garden, or if you use a little gnomon, a little stick in your garden, and you measure the tip of the shadow where it falls at noon every day, or perhaps weekly, or once every 2 weeks, across a year, you will also see this beautiful analemma shape being drawn out. So these are all different ways of measuring the length of a year. So firstly, the tropical year, this is now the solar year. Finally, the other method that can be used to measure the length of a year is looking at the positions of the stars in the sky. You will see that from our perspective on Earth, they also appear to be moving around us. Of course, we know now that we are moving around the sun, and the background of the stars is actually stationary. But it appears from our perspective on Earth that the stars are moving around us. And the best way of viewing this is seeing which stars come up on the horizon at a certain time. Normally people use sunset or sunrise so that they have a position to compare against. So this gives you an idea of the length of a sidereal year, coming from the word star. So this is a sidereal year. So you can see that I've already mentioned, we've talked about days, months, and now 3 different types of years that it's possible to measure. Now, it becomes a very complicated system because the number of months doesn't equally go into the length of a year, so this creates really a lot of complications. And the way in which you decide to measure your year and the type of year you're choosing to measure also has an impact on the kind of calendar system that you can develop. But it's possible to see that from a very early stage, these repeating cycles in time, these indications of a passage of time, were very influential for civilizations. So you can see way back to the ancient Greeks, if you look, it's approximately 8th century BC. You can see in the works of Homer, people are already using the position of stars and the position of the sun to be able to navigate. People are already using this kind of information to decide to make agricultural decisions. When should we sow our seed? When should we harvest? So calendars in some form are already very important to these ancient civilizations. These days, we have calendars that have developed from all of these different measurements. So you have lunar-based calendars, such as the Jewish calendar, and then you have calendars that are based on the solar year and also the sidereal year. There are, I think, more than 40 calendars still in existence today, and I'm only here for an hour, so I only have time to talk about our calendar, so that's what I'm going to stick to as a topic today. So our calendar is a Roman calendar. The Romans were heavily influenced by the Sumerians and the Babylonians before them. So some of the ideas that they were influenced by come from older civilizations. However, our calendar is a Roman calendar, and it originated from Romulus, who was the first king of Rome. He decided to try and sort of make a mismatch of two different types of calendars. We've already looked at the lunar system and we've looked at the solar system. And he was trying to sort of force these into one type of calendar. And these types of calendars are known as lunar solar calendars. Now, back then, the Romans had a reverence for the number 10, most probably because they used their 10 digits to count with, so it was a very convenient number to use. And you can see back in history that Romulus actually, he liked the number 10 so much, he divided his Senate into tens, he divided his military into tens. So what he decided to do was, hey, we're going to have 10 months in a year. And this is how our calendar started, which is kind of a complicated thing to do. So he had his 10-month calendar, and then he had these sort of extra days that he didn't know what to do with. So his calendar looked like this. It began in March because the year begins in March. It's when spring begins. It's when things get born. You know, it seems like a good time to start a calendar. So March, and you'll see here the lengths that he gave these months and also where the names originate from. So the first few months were named after Roman gods. And then he kind of ran out of god names, so the next few months were literally just named after the number of the month. So you can see Quintilius, quint is the Latin for 5, we get sext, we get September, October, November and December, which are quite familiar to us. And this is the reason why sept comes from the Latin word for 7, and it was originally the 7th month. So if any of you have looked at your calendars before and you've thought, well, I know oct means 8, why is it the 10th month in the calendar? That's because January and February didn't exist in this time. So these were the first original 10 months. Now, if you add up all of these days, you get these 61 sort of leftover days. These were unlucky days, or thought of as unlucky days. And they were so unlucky that they didn't want to give them a name. So they were just sort of hanging on there in the winter after December. And they're sort of known as intercalary days, days that belong to a month with no name, and they're there to pack out the calendar, because what you want is to have months that are related to the lunar cycle, but the year is related to the solar cycle. So in some way you have to get them to match up, even though in reality they don't match up properly. Okay, so that's what his original calendar looked like. Now, the second king of Rome was Numa, and this was only about 40 years later, and he went, well, you know, odd numbers are lucky, so let's change the months around and get rid of these 30-day months and turn them into 29-day months. And then we're still left with the 31-day months. And it was his idea to create 2 new months. So this is where our January and February came from. You still had the problem that there were these, like a few intercalary days that were left over. So instead of what we have now, which is this leap year system where we have a leap day, so we've got a leap day this month, in fact, they had a few days that they would package up into like a leap month that they would have every few years to keep the lunar cycle and the moon in sync with what was going on in the solar calendar. So that's what they decided to do. So his calendar now started with January, February, and then there was this 3rd month called Mercedonius, and that was the intercalary month. So it wasn't every year, it was just every time they decided things were slipping out of alignment, so that they had to stick that month in there. And he changed all of the 30-day months into 29-day months because of this fascination for odd numbers. Okay, so let's talk about Mercedonius and the reason why we don't have that anymore. The word Mercedonius comes from the word mercies, which means wages, right? So in this month was actually the month when people got paid, soldiers got paid yearly, for instance. And at this point in time, calendars weren't public. So people didn't know what the date was. The high priests were in charge of keeping the calendar, and they would announce important days to the public. So that's the only way that you knew what date it was, if an announcement was made. So it was up to the high priest to decide when Macedonius was going to be introduced as an intercalary month. Well, sometimes the high priest decided to use this to their advantage. If they liked the politician in office and they wanted them to have extra time in office before the next elections, then they'd go, oh, let's add in another month there. If they wanted to charge people more interest, for instance, or they wanted to skip out on paying people, oh, we'll just skip the payment month this year. So there was a lot of random introduction and disuse of this month. And what this meant was that everything kind of became very chaotic and slipped out of alignment. And that's something that I'm going to go on to talk about. But first I want to talk about the other big change that Numa made. He decided to fix how the days of the month were named. If you look up a Roman calendar on Google, you see this kind of thing. And you might wonder, well, how do you read this thing? What did a Roman calendar look like? So what I thought would be fun to do, because I'm a physicist and I think this kind of thing is fun, I decided to take our calendar and superimpose a Roman calendar on the top of it to see what it would look like, right? So this is February of this year. The first thing I've got to say is that Romans didn't have a 7-day week. I'm going to come to weeks later, and so it would have looked slightly different. So they had their months in lists, right, rather than in this. But so that we understand what's going on, I've drawn it out exactly as our calendar looks this month. So the first thing to label is the kalends. The kalends is the first day of the month, and when people like the Babylonians used purely lunar calendars, the kalends was always the day of the new moon. And this is where the word calendar comes from the word kalends. So the first of the month, they wouldn't have had numbers, the first of the month would have been the kalends of February. The next day that was named was the Ides. Perhaps some of you have heard of the Ides of March. The word Ides means to divide, so we'd literally be dividing your month in half. So for short months that were 29 days, then the Ides would fall on the 13th. For longer months, it would fall on the 15th. The nones, like the word novum in November, means 9. So 9 meant, Romans do this thing, they count backwards and they count inclusive. So think like a Roman, and you go from the Ides and you count back by 9, inclusive of the Ides. So this gives you 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 9th day before the Ides, inclusive of the Ides, is then the nones. Everyone with me so far? Good. Right. They do this thing where they count backwards, and for the first day that is behind something, one of these days, is known as pregia. This apparently somebody who speaks Latin has told me that this is pronounced as pregia. So the pregia nones of February would be the day before the nones of February. Hence, the pregia Ides of February, the day before the Ides. And this would be the pregia of the kalends of March, because obviously the next day would have been the kalends of March. So that gives you that date. And then all of the rest are just given a number that counts back from either the kalends or the nones or the Ides. So this, and don't forget they count inclusively, right? So I'm getting lost myself. So this is the day before the kalends of March, but this is the third day before the kalends of March because you count from this one. So you include the one that you're counting from. So 1, 2, 3. And then this would be the third Ides, this would be fourth Ides. I can fill this whole thing in. Today is the 13th kalend, the 8th kalend of March, because we're counting back from the kalend of March, so that's what day we're on today. And I can fill all of these things in, take away the numbers, and that's pretty much what a Roman calendar looked like. And the other thing that they did is if there was a feast day or a bank holiday, so we had Carnival here in Maastricht a week or so ago, then they would be highlighted in red on their calendars, on their written calendars. And that's where the term a red letter day comes from. So their calendars would look like this. So these are each of the months. So this is January, February. So basically they listed everything. And as I say, they didn't have the 7-day week. actually what they did was they labeled all of their days A through to H, and then A through to H, A through to H. And what they had was a sort of 8-day market week. So in your area, your market day might have been on the letter B. So the next time the B comes around, that is your market day. So that's how this worked. One disadvantage of having a calendar like this is I've already talked about a calendar reform. I talked about how Numa changed the amount of days that there were in the calendar. Well, if you do this and you count like a Roman, this makes things horribly complicated, right? So, anybody got a birthday in February? When's your birthday? 2nd of February. Okay, so let's pick somebody else. Okay, no. So the problem is, because they can't count backwards, say if your birthday was at for example, this week, right? So where are we at the moment? We're on the 8th Kalends of March today. If I decide I'm the next Roman king and I decide to take away 2 of the days, then when should I celebrate my birthday? Because all of these numbers then shift. So would I celebrate my birthday today as it is, or would, if I took these 2 days out of February, would I then have to celebrate 2 days earlier? So when they made these reforms, people didn't know when they should celebrate. And actually, some people ended up just celebrating twice. So things got really messy with the saints' days and feast days and things like that. So it's a horribly complicated system. So I said when I talked about Numa, he decided how we were going to call all of the days in the calendar. But he also introduced this Mercedonius, this intercalary month. But people just decided to add it and retract it whenever they wanted. And what this meant was the entire year had kind of moved out of alignment. So don't forget, in March was supposed to be aligned with spring. Well, by the time we get to 46, 45 BC, the year had gone so far out of alignment due to this intercalary year that actually the springtime was happening in the middle of winter, or March was happening in the middle of winter, or winter was happening in March. You know what I mean. That's what I'm trying to say is it was cold, right? So they knew something was wrong, and Julius Caesar then made the next reform. And what he did was he decided to get everything back in line by introducing all of the days that had shifted out of alignment into one year. So in the year 46 BC, he decided to add all of these extra days so that the year was actually 445 days long in total. And that brought everything back into alignment. It shifted March back into the springtime where it was intended to be. After that, he also introduced a leap year system, which is very similar to the leap year system that we have now. So he decided that there should be a leap year. He'll get rid of the intercalary month, and we'll have a leap year system, and a leap year once every 4 years. So January and February were still there. Mercedonius was abolished. He changed some of here we go again. He changed some of the numbers of days in the months to get things close to alignment, and then we had a leap year. And the Senate was so happy that they decided to rename Quintilius to Julius, which is where we get July from. I have a thing about why do we need intercalary days, but I've already mentioned that things just don't line up. We want there to be order, and we're trying to measure order, but actually the rotation of the Earth on its axis and its orbit around the sun don't match up exactly. So that's why you need these intercalary days, months, or leap years as we have. Now, 2 years after he reformed the calendar, Julius Caesar was killed. People thought that's because he messed with the calendar. Because they thought, well, the calendar is God-given, right? It's decided by the sun. The sun comes from God, so this is the reason why he's been murdered. But what happened then, after he'd tidied up the calendar and he'd introduced the leap years, well, after he died, all of the high priests kind of went, what was the rule? A leap year every 3 years, was it? And they literally put a leap year every 3 years, and everything just went like completely out of alignment all over again. So about 40 years later, Augustus had to come and fix everything again. So you get another reform taking place. So Augustus decided to correct all the mistakes that had been made. He did this slowly over a 16-year period. So instead of putting loads of days in to put things into alignment within 1 year, he did this slowly over 16 years, adjusting the days here or there. So eventually it came back into alignment. However, the leap year system, with having a leap day like every 4 years, is actually too long by 11 minutes. Now, 11 minutes a year doesn't sound like a lot, but if you think this was in 8 BC, right? So 11 minutes a year over thousands of years makes a huge difference over hundreds of years. So this is a point that we're going to come back to a little bit later. Anyway, again, the Senate were so happy that they decided to name the month of Sextilius after Augustus, and that's where we get the month of August from. Also, because July, that was named after Julius Caesar, had 31 days, there was no way that the month of Augustus was going to have 30 days. So he had to get one more day in his month as well. So things kind of got moved about a little bit more. So this is how things stayed for a little while. I'm going to jump to Constantine, who is the first Christian emperor. He introduced the 7-day work week. So this is the week that we have today. And he also introduced Sunday as a holy day. So where did the days of the week come from? That's the next thing on the schedule. So this comes back to a Babylonian system. If you look at the sky, you see the stars. They are all generally moving together across the sky at the overnight, and within a year, everything comes back into alignment. But you'll notice that there are certain celestial objects that don't follow the same pattern as the rest of the stars. And in Greek, they were known as the wanderers, and the word wanderers in Greek is planets. So they knew that there were 7, what they referred to as planets, but they also included the moon and the sun in this case. These were the 7 wanderers, and these were special because they didn't stick to the same rules as everything else they could observe. So what they did is that they put these 7 planets into a hierarchy depending on the period of orbit around the sun. So they had this list, and you might think, okay, we've got 7 planets, that's where we get our 7 days from. But the Babylonians didn't make life as easy as that. So what they actually did was they took the 24 hours in a day, and they named the hours in the day after the planets, okay? So if I label all of my hours with all of the planet names in hierarchy order, obviously I run out after 7, so I keep doing that, and I keep doing that, and 7 doesn't go into 24 nicely. So what you have is in the next day is you have a different planet at the start of the next day. And if I go across, it takes exactly 7 days for this pattern to repeat. And it was the first planet of the day which was known as the dominant planet. And it is these days that give our week, it's these planets that give our days of the week their names. And this is really obvious to see with some of the planets. So Saturn and Saturday, Sun and Sunday, Moon and Monday. The others are easy to see in certain languages. So I've picked French here, and that's very obvious that you get Mars Day and Mercury Day. What happened was that when the Romans invaded places like Britain and Germany, the British decided that they wanted to take on some parts of Roman culture, but they didn't want to take on everything. So what they did is they changed some of the day names to be the same as Anglo-Saxon gods instead. And you see equivalences of these for German gods as well, giving you the day names in Dutch, in case people were wondering. When Christianity took hold in Rome, then also Sunday was often changed to the day of the Lord, which is why you see a different name for Sunday in some languages. The other thing that he did was he convened the Council of Nicaea. This was a big Christian council of about 300 bishops. They had to decide on some theological disputes that people there was no consensus on a few things during this period. But one of the other things that took place during this council is that they wanted to come up with a formula for the date that Easter was celebrated. Before this date, Easter was, it was known that Christ was resurrected during the Passover, the Jewish feast of Passover. So they'd always followed the Jewish calendar. But at this point, they wanted Christianity to move away from its dependency on the Jewish religion. It's a completely separate religion. We shouldn't be relying on their calendar, was their thought at the time. So they had this meeting to decide what the formula for Easter would be. And they decided that Easter was going to be on the first Sunday after the first full moon after or on the spring equinox. So that's the rules for Easter and when it's celebrated. However, you need quite good astronomy to be able to work out exactly when the spring equinox is. And also, the spring equinox can happen at different times on different parts of the Earth. So there's some disagreement, or there could be disagreement about the exact date. So instead of using astronomy to work out when the equinox was, they just set the equinox as the 21st of March. So that's how Easter was left. And this is going to come back to us in a little while. Not so long after this council was the fall of Rome, and you enter into the Dark Ages. During this time, a lot of information was lost. But this is one area of history that I find very interesting. Normally people think perhaps religion, and especially Christianity, and the development of science are very much divergent things. They contradict each other. But actually this is a period in time where if it wasn't for the fact that the Catholic religion at the time wanted to know the exact date for Easter, that's why science was promoted during this period. Astronomers were very important, mathematicians were very important, because people needed to be able to make these calculations. So one thing was promoting the other. So during this time in the Dark Ages, monks were very busy also thinking about time. They needed to know what time to pray. They were also Denis the Small, I can't remember his name in Latin now, Denis the Small, deciduous, exiguous or something like that. Anyway, he did a lot of work on he developed the AD and BC system that we use today. And it's worth historians noting that before that was implemented, actually years were just discussed on who was reigning at the time. So you didn't have 800 BC and 59 BC. You didn't have that kind of clarity. You would say, oh, that was the second year in the reign of, and you're specifically talking about an emperor or king who's reigning at the time. That's really confusing, because then you have to have historical context about what was the order that people were reigning in, otherwise you don't know. And what happens if somebody comes into power halfway through the year? Is that their first year, or is the next year their first year? So this means that there's a lot of doubt if you look back in historical texts over exact dates during this period. Now, if we move a little further forward, you see certain developments. So things like the printing press and trade and communications travel was improving during these periods. So actually the calendar was made more public because of having printing presses. And that meant that people were aware that actually, I said that the Julius Caesar's system of having a leap year every 4 years was slightly flawed. It's 11 minutes too long. Now, this was hundreds of years later, and people are starting to notice, actually, people are celebrating Easter at the wrong time, because it was possible to see with astronomical observations that your 21st of March, which was set as the date of the spring equinox, was drifting away from the spring equinox. The spring equinox is when your days and your nights are of equal length, because you have no tilt towards or away from the sun at that point. So this was easily spottable. So the problem is that the Christian religion at this point was being mocked by other religions. People are saying, well, if you're celebrating Easter on the wrong date, well, then you're stuffing your faces when you should be fasting, right? So you're making a mockery of your own religion, and this is something that really had to be fixed. But mathematics wasn't good enough at the time. So nobody really knew how to deal with this, and nobody really had the power to deal with it, although there were a lot of attempts. It wasn't until the 1500s when Pope Gregory the 13th had enough backing to be able to implement a further reform, and it's actually the Gregorian calendar that we use today. So he decided which year to use, and I was talking about tropical years, solar years, and things like that. And he decided on a new leap year system. This, if you see the years that this was implemented in 1582. This is an interesting period because the church was trying to, at this point, stamp down its authority a little bit more clearly straight after the Reformation. So this was, in some countries, this reform of the calendar was seen as a papist plot. So he decided to fix the calendar and move everything back into alignment by removing 10 days, because the calendar, we'd been adding 11 minutes to the calendar for hundreds of years. So it was now 10 days out of sync. Catholic countries tended to take on this reform quicker than others. Protestant countries took it on late. It was chaos because in this country, for instance, the Catholic areas in the south took on this new reform, whereas in the north they didn't. So in one country you had places being 10 days out of each other. So the calendars were really confusing at this period. There's also people saying that there were riots in the street because people were like, I've lost 10 days of my life. And people were saying, well, I'm not going to pay my rent for this month because it's 10 days shorter. I should have a 10-day discount. There were all these sorts of arguments against it. For instance, the Orthodox Church didn't take this on until the 1920s. And even now, they still calculate Easter to the old date. So they've taken it on in some parts and not other parts. The UK, for example, took this on nearly 200 years later in 1752. And they took it on so long after that they had to take off another day because it was already 11 days out of sync. So this was a huge mess. It didn't really bother people very much at the time because there were no newspapers and there was not as much travel, and people saw it as just checking in your date when you travel, like in the same way that we check in our money if we want to travel abroad and change it to something else. So it affected people personally in some ways, but it didn't affect countries like you might think it would today. So his new leap year rule was that you have a leap year every 4 years apart from on the centuries, except if the centuries are divisible by 400. So these ones in red you skip, but the ones in blue you would keep. And that is what now keeps our calendar in sync with what's actually happening in the natural world around us. And these graphs show you the Julian calendar drift, and the Gregorian calendar drifts out of alignment with the spring equinox and then jumps back, and it drifts away and jumps back. And that's what's happening with these leap years. Okay, ironically, I need to keep an eye on the time. So why is this all so hard to measure anyway? Well, I've already described the fact that we really like order and we want to be able to measure things and see that there's a common pattern. But there isn't always order in nature. It reminds me of those little boxes that kids have to put the shapes in the right holes. And in this case, they don't fit. So that's what's happening. If you look at how a day is defined, for instance, if the Earth starts in this position facing the sun and it rotates around, so it's rotating, spinning on its axis and orbiting at the same time, by the time it gets to position 2, you have the same stars that were over here that would be visible from this position. So this is a definition of the sidereal day, whereas the solar day is the time that it takes to rotate that little bit further so that you are facing the sun again. So you have two definitions of a day. So which do you want to use as a day? And the same is true whether you are looking at the month. Let's see, how does this play? So if you're looking at the definition of a month, it also has two definitions. It has, when it's sitting between the Earth and the Sun, you get a new moon. Should move on. Maybe it's stuck. appears to be stuck. And then as it rotates around, once it's in the same position relative to the Earth, then that will give you a sidereal month. And then once it's in the same position relative to the sun, that will give you a solar month. So with all of these things, you have many different definitions to draw on. And that was the same when I introduced tropical year and a sidereal year earlier. So it depends which of these you want to use for your definition, and that's why things are such a mess. The last thing that I wanted to talk about while I still have time in the next 15 minutes is we've discussed all of the big items of time, right? So we started by talking about months and the lunar cycle. We talked about the years. Now I want to talk about, well, all of those big cycles, they're all based on something in nature. So they were based on the sun, they were based on the moon. I want to talk a little bit about smaller units of time. Where does an hour come from, for instance? And these are more artificial measures that we have created to be able to define smaller units of our day, basically. So when we talk about hours, well, it was the ancient Egyptians who first decided to split a day into 12 hours. They decided to split it into 10 hours and plus 2 twilight hours, twilight in the morning, twilight in the evening. So that gave you 12 hours. And they were unequal hours because we know if we live away from the equator like we do here, then in the summer, our daylight hours, our daylight, the length of daylight, is longer than in the winter. So because Egyptians only counted hours during the daylight, the length of the hours changed throughout the year. You would have long hours in the summer and short hours in the winter. And this was totally normal for people. They didn't mind. They thought this was a more productive way to use the day because it told them what proportion of the day that they had available to them to use. So to them it was logical. Even when the first watches and clocks were designed, people would reset their clock to match unequal hours because that's what they wanted to know. And for us that's a really sort of different way of thinking now, hard to understand. So they didn't count any time during the night time, but it was the ancient Greek astronomers wanted to be able to do astronomy at night. So they were the first ones to also split the night time into 12 hours. And it was astronomers also who were the first ones to use equal hours because they wanted to know exactly what time something would reappear in the sky. So equal hours were more important for astronomers. The first types of devices for measuring time were sundials, but the first sundial wasn't called a sundial, it was called a shadow stick. This is an ancient Egyptian shadow stick. It didn't really give you an indication of hours, it gave you more of an indication of how much of the day had passed. And because it's a stick like this, and you look at the length of shadow on the stick, this is where the English phrase, the length of time, comes from, because you would have a look at the length of time you had left of your daylight. And it was a lot later, actually, that sundials were invented. Sundials were invented and clocks were invented later in the northern hemisphere. And clocks were based on the direction that the shadow moves on a sundial. And that's where we get the term clockwise and the direction clockwise from, because the clockwise direction followed the sundial direction. So had sundials and clocks been invented in the southern hemisphere, then clockwise would also be anti-clockwise, not to confuse anyone there. Okay, so sundials, no good at night time. Sundials, probably no good in this part of the world where it's very rarely sunny. So the other inventions that you get during this time are water clocks, so people had to have a good knowledge of physics, and candles and incense. The first ever alarm clock was a candle with a pin stuck in the side. So when the candle melted, the pin would drop into a metal tray and that would wake you up. And incense clocks were quite interesting. You even got ones that had a different aroma at different times. So you could tell the time just by smelling at this point. So there's some very nice inventions. When clocks were first, mechanical clocks were first invented, the people didn't have them in the homes. People would have them mainly in churches. There would be one per village, so you didn't know the time personally, but you would have to go out into the village. And they didn't have dials on them. In fact, they just sounded the time via a bell, and the word for clock comes from the German word Glocke, which means bell. Because that's what they did. They sounded the hours. People wanted to know the hours, but they didn't have so much interest in time in between hours. So that's where the word clock comes from. And it's not until 100 years later that you see the development of mechanical clocks as we think of them now with their dials on. And in fact, the first dial clocks had the full 24 hours around them, rather than the 12-hour ones that we're used to now. So that was my question. There was another question. People often say, well, why are there 60 minutes in an hour and 60 seconds in a minute? Well, actually, this comes from mathematical convention. I told you how Romans like the number 10, because you can count 10 very easily. Well, the Babylonians and the Sumerians really like the number 60. And they used the number 60 in their sexagesimal system. They used to count differently to us. So they would count the number of bits of your finger. So on one finger, I have 3 segments, and I have 4 fingers with 3 segments on this hand. So that gives me 12, and then I can do multiplication. I can do 12 times 1, 2, 3, 4, 5, and I get 60. So they use this system for counting. And 60 is a very good number if you want to divide through and not have any fractions. So it has a lot of factors. So mathematically, the number 60 is very convenient. At this point in time, they didn't have knowledge of fractions. So they wanted to pick a large number that was easily divisible so that they could always work in whole numbers when splitting things up. So that's where the 60 comes from. And they were also the first people to split a circle into 360 degrees for the same reasons. I want to spend the last 10 minutes of my lecture just bringing you up to date, basically. So we've gone right from the past, and we're sort of getting there. We're in the 1700s now. The last thing that I want to talk about is about transportation, navigation, and time, because these things have all affected the development of time. So in the 1700s, this was a period where you were getting a lot more trade, you were getting a lot more transport across the globe, and you were getting a lot of shipping disasters during this time. There were huge disasters, and in Britain, as well as in many other countries, a reward was offered for somebody who could invent a safe method for navigation. And this really promoted the development of clocks and watches and timekeepers in general. The way that they used to the methods that they used to use for sailing and navigating was dead reckoning. So this was, if you knew where you wanted to go, measuring your latitude, how north or south you are, is very easy to do by the sun or by the pole star. So you could do that, and you would travel north or south, mainly north, and then you would use a compass to try and travel directly in a straight line east or west to your destination point. The problem with doing that is that people knew that there was only one route you could take, so it was very easy to get hijacked by whoever else is after whatever it is you're carrying. So this was a big problem. And navigation was dangerous in this method anyway, because to use dead reckoning, you also needed to make estimates about how fast you were traveling. So people would tie knots into rope and let the rope out of the end of the boat and time a certain amount of time and see how many knots had slipped through your fingers, hence where we get the term, the unit for measuring knots from. That was actually very difficult to do because of surface currents and things like that. And also using a compass to judge your direction east-west is not very good either, because this actually varies throughout the world depending on where you are. So measuring latitude was something that was very easy to do, and as I say, you can use the elevation of the sun above the horizon to do this, or the pole star and things like that, and it's just a question of geometry. But when you want to calculate your longitude, your distance east or west of something, then you really need a good timepiece to be able to do that. And at this period, there wasn't anything that was really reliable. So if you have a timepiece and you set it to noon when you leave Maastricht and you travel far away, if you measure what time noon, when the sun's highest in the sky, when you measure that time at your new location, if you know the difference in time between your noon that you're viewing where you are and what it was back home, then you can work out how far around east or west you've traveled from that position. So that's why they really needed a good timepiece. And that's one of the promoting factors that took place during the 1700s. In the other way, railways and the development of railway transport across countries, especially America and Canada, big countries, really changed how we perceive time. Before the development of the railways in the 1800s, actually every city kept its own local time. So you could go from here to Heerlen, and Heerlen would have a different time. Here from Valkenburg, and Valkenburg would have a different time, because everybody was measuring the time relative to the position of the sun. So it was really complicated, but it didn't really matter before the railways, because it took me so long to walk anywhere that by the time I got there, it didn't matter that the time was different. Whereas when the railways developed, people for the first time were able to travel long distances within a short period of time. So they were noticing these differences more and more. And what was worse, especially in big countries like America, if you got to the train station, the time of the train you were catching was dependent on the station or the company of the train that the train you were catching was from. So if I was in New York and I was catching a train from Columbus, I would have to know where the train from Columbus came from. If it came from Columbus, it would be on Columbus time. And the time I was catching it in New York, I would have to recalculate what the Columbus time was relative to the time that I am, basically. This doesn't make any sense. That's how it felt. It didn't make any sense. You would go to a train station, there would be 5 different clocks on the wall. If you were catching the train from Columbus, you would have to know what time on Columbus time it was going to be at your train station, and then work out what it meant to you. So this was a complete mess. So in the late 1800s, in 1884, 1887, that period, standard time was introduced. So that's when the world was basically split up into 15-degree segments that would all have one set hourly time. So that was the development of standard time, and that's pretty much how it remains to this day. It can be a little bit more complicated depending on the borders that countries have, etc. The other complication to standard time was that before the war, an idea was introduced to have daylight savings time because it would allow people in far away from the equator like we are to enjoy more sunlight hours in the summer. But it wasn't an idea that took off, and it didn't take off until the Germans wanted to save money, save fuel during the wartime to put towards the war efforts. So they decided they were the first to decide to introduce daylight savings time. But this adds complication to standard time because some countries use it, some countries don't. In America, there's a state that does have it, but there are areas and reserves within the state that don't have it. And all countries choose to implement standard time on different dates, and daylight savings time on different dates. So everything comes in and out of alignment again, just to make it more complicated. The war also had other impacts on time. If you've got jeans or trousers, they often have, especially in men's trousers, in the pocket, they have another little pocket in there. That pocket was designed for wristwatches because before the First World War, it was very uncool for men to wear wristwatches. It wasn't until during the First World War that they couldn't be rummaging around in their pockets to find the time, so they had to have it in a more convenient place, and then it became more acceptable for men to wear wristwatches. So that was the other implication of the war. And to finish, I just want to talk about the technology that has moved on to today. So now our technology in measuring time has become better and better. So we have quartz clocks and quartz watches. Quartz is a crystal, and this crystal has it's called piezoelectric properties. So if you run a current through this material, the crystal will vibrate at a given frequency. And that given frequency is the frequency that is used to control your timepiece. So that was one of the first developments in these types of watches in the 20s. And digital clocks as well rely on microchips and transistors to do frequency division and counting and mathematics based on either if you've got a main signal from the wall and an AC signal. And the final thing to talk about is what we are using today. Today, the definition of a second is very different from when it was first defined. So we've talked about the length of a day, and the average solar day we've talked about already, and that is how a second was defined. It was defined taking the length of a mean solar day, and you divide that by the 24 hours, then the 60 minutes, then the 60 seconds, and that gives you your definition of a second. The problem with that, as well as it's very difficult to measure what a solar day is, the solar day actually shifts at different times of the year. So the orbit of the Earth around the Sun isn't a circle, it's actually an ellipse, and the Earth travels faster when it's closest to the Sun than when it's further away. And also the tilt of the Earth relative to its orbit also makes a difference to how long the solar day is throughout a year. So this measurement for 1 second isn't something that can be easily measured, and it's not something that's very consistent. So in the 1960s, scientists wanted to have a set way that a second could be defined and measured everywhere in the world, so that we could have consistency between countries and we could have consistencies with measurements. And it was then that they decided to choose the vibrations of a cesium atom, once it's in a microwave, as the definition of a second. And this gives you a very accurate and reliable method to use. And it's this definition and it's this technique that is used in atomic clocks, and that's what we use today to control all of our timepieces, and we set all of the rest of our quartz watches to be consistent with what the atomic clocks are saying. And if it wasn't for these atomic clocks, we wouldn't have the GPS navigation that we have today. So we've sort of gone from having navigation at sea promoting the development of clocks and watches to now we have an atomic clock, and it's helping us to navigate once again. So hopefully you see in this talk that all of this history has not only, and development has not only led us to know when we are, but we now know where we are because we know when we are. So I'm kind of hoping that this talk has answered some of your questions about the development of time. Perhaps if anyone says that they want to have a meeting with you next week on Monday at 4 o'clock, you'll think twice about, oh, well, where did Monday come from? And where did these hours come from? And where did the week develop from? And perhaps you'll have, I don't know, developed an appreciation from all of these theologians and emperors and kings and popes and astronomers and mathematicians whose influence have led us to have these forms of time and divisions of time that we take for granted every day. Thank you very much.